Hello. So the next lecture I'd like to go over is on exponentials, and again, what exactly the language is saying when we describe what exponentials are. And it's pretty much a language to describe growth in mathematics. Again, it's a language, it's just a better way of, or an easier way of describing a phenomenon. And so certain things grow in certain ways, and it's convenient to have this type of tool. And I'll go over first something that is conceptually maybe a problem in the language of mathematics, and that's when you have nothing, and we'll talk about nothing again as zero, and then you take that nothingness, nothing times. That means that in this case, if I have something, for example, and I take it one time, and I take it one time again, there's no growth. Or if I take something, whatever it is, and I take it two times, but then I take that new something two times, and I take that new something two times, you could see it's growing by twos. Each one of these is growing into a new two. Or in this one, each one of them is growing into a new three. And this one's growing into a new three. And so is this one. So this is describing how something is growing over time. Or just growth in general. So here, utilizing the same concept, if I have nothing and it's at the original state before it's even grown, that's pretty much what zero is saying here. Nothing in its essence. Well, we don't know what that nothing is. Is it truly nothing, or is it something? All we can say is that whatever this state is going to evolve into either a something, or in the case of zero by mathematics, it'll remain as nothing. So what math is saying is, okay, it's like, I don't know what this state is. It could be nothing. It could be something. So we'll call it undefined. Or some people will argue that it is zero or it is one. But it's pretty much undefined. So then the question is this nothing gonna... We know it's going to evolve into nothing because that's what the language is telling us, that it's never going to evolve. But we don't know what this state is. So it's either nothing is going to remain as nothing always, or we started off with something and it's going to shrink down into and vanish into nothing. But what we started with is indeterminate, and that's what's going on. So we're describing the growth of something, but we don't know what that something is. It's unknown. It's up to us what it could be. It could be anything we want it to be. It could be an apple or an elephant, or it could be a number or whatever. The language is just trying to say that whatever this is we start with, it's going to not grow at all. It's going to become nothing. If it started as nothing, it will remain as nothing. It will grow into nothing. And if it started as something, then it will shrink down and vanish and remain nothing. So that's the interpretation, at least my interpretation, of what's going on with this. We could look now at 1. So the same thing is that if I have 1 to the 0 power, this could have been nothing again. And again, the point is that we don't know what this state is. It could have been nothing. It could have been something. In this case, I have it as something, but certainly you could imagine it as nothing because we don't know what this state really is. In math, we define it as 1. Anything to the power of 0 is 1, or it's unity, or it's whatever it is, because it can't be determined at this state because we don't know what exactly is growing. At this point, we know that we have 1, and at the next point, we know that we have 1. So we have no growth here. It stays constant. We don't know what we started with, But we could follow the pattern back, and if I have another one, we could see if I have another one here, that it will just, whatever it is, stays constant. But what the original state is cannot be known. Now we'll see why the pattern is, again, it could only go back and make sense until we get to what number we're dealing with. But where it's evolved from, where it's grown from, that's kind of an unknown territory. So if we have 2 and we have 2 to the 0 power, again, we have something here. It could be 1. It could be 1 over 1 or 2 over 2 or 3 over 3, which all equal 1. Or it could be infinity, or it could be 0. We just don't know. What we do know is whatever from that came into something called 2, which in mathematics is represented, and I guess, I'll use pizza pies again, as this pizza pie and that pizza pie. And then each pizza pie, which is what the growth is telling us, exponential by 2, is I'm going to take this one. Here I had 2 to the 1, 2. And I'm going to take each one of those and go 2 from that. And this one, 2 from that. And then here will be 2 to the 3rd power, which we know is 8. So what happens there, this is 2 to the 2nd. I'm sorry, I didn't put 2 to the 3rd, but it's there. And so it's 2 from each one of these. So we get 8. And then we get 4. And then we get 2. But what developed into the 2? Was it one pizza pie that grew into 2 pizza pies? Did we never have a pizza pie and we baked one and then we decided to make 2 pizza pies out of that? Did we start out with infinity or whatever, 25 pizza pies, and we said, hey, you know what? I'm going to throw out 23 of them and I'm going to start with 2. Then we'll get 2 here and then we'll continue in this growth pattern. This is the big unknown. So this is what's going on here. The same thing with 3. We have the same problem. We can follow a pattern. It goes from 3 to 1, and then 3 to 1. And of course, if I went here, it'd be 3 to this one, and 3 to this one, and 3 to this one. And the pattern could be followed backwards. That the pattern is by 3s, and every one of these is multiplying, or is dividing itself into 3s. And all's fine and dandy until we get back to here. These 3 are going back to what? To the original 1. What's the original 1? Well, we don't know what the original 1 is. It could have been like before, nothing. 3 pizza pies grows, we start baking it and we make 3 pizza pies. But originally we had nothing, and then we put the flour and the dough and all the stuff and we made pizzas, 3 of them. Or this could be, 1 pizza pie, and then we made 2 more pizza pies. But we don't know what this is. We could define it any way we want. Like I said, it could be infinity. This means unity. This could be nothing. It could be whatever we want it to be. It's really like undefined state. It's the same thing here. 4. It could be nothing. It could be something. We could follow the pattern back. But we can't know what this ever is, because that's up to us what we're growing. We don't know what we're growing. We just know that this is the growth pattern that's happening. But what's growing? Well, we don't know. We don't know if it came from nothing or from something. So pretty much, in summary, where the growth starts from is up to us. The pattern can be followed back to the original state. However, the observer is going to decide what that original state is. Exponentials can only give us a pattern of growth. That if each one of these were human cells, that each one of these cells is dividing 2 times. Can we say that this was the original cell that it came from? Sure. Then we can make that 1. Or could we say that this was 8 cells that then 6 cells died off and started with 2, and then the growth started in this way? We could do that too. We could say that there was nothing there, and then a cell grew out of nothingness. And the point is that we don't know what happened there, but we do know that after when we started observing, that we're now observing this pattern, and we're describing this observation using this language of exponential growth, which can be a useful language because certain things do expand out in this way when we see them in nature or what have you. So, again, mathematics as a tool and as a language. Thank you.